Oh, yeah. Today we're having a little throwback lesson from geometry. We're going to learn to solve for missing sides in special right triangles. Go ahead, take 30 seconds to copy down today's objective, and if you'd like, to start this picture of Pythagoras, the king of triangles. Start to wrap up. All right. Before we begin today, some quick vocabulary. Hopefully you remember this from geometry. Similar shapes Similar shapes have the same shape but different sizes. That's if they're similar. So you can see these two triangles, they have the same shape. You can see they're both scalene triangles. They have three different side lengths. Okay? And their angles are the same. Their angles, this angle and this angle are the same. This angle and this angle are the same. This angle and this angle are the same. Okay? So they have the same shape, but all that's different is that this triangle is bigger than this triangle. Okay? It's as if we've taken an iPhone. It's as if we've taken an iPhone and we've started with a, let's say, a small triangle, and we've just sort of pinched it out to zoom. It's the same shape, just a different size. Okay? That's the idea with similar shapes. So, today we're learning about two types of special triangles. We're learning about the special triangles that are based around their angles. So the first type we'll learn about are 30, 60, 90 right triangles. And they're called that, of course, because their angles are 30 degrees, 60 degrees, and 90 degrees. Okay. This right here is the model 30, 60, 90 triangle. Okay, the model 30, 60, 90 triangle. So let's notice a few things about this. Okay, first thing we want to notice, okay, the three sides are different lengths. Okay, we have one side that's the short side, we have a middle side, and we have the hypotenuse, which is always the longest side of a right triangle. Okay. Next thing you could notice is, okay, well look, the shortest side is opposite the 30-degree angle. The middle side is opposite the 60-degree angle, and the hypotenuse is opposite the biggest angle, which is 90 degrees. Okay. That's how you identify which side is which, or which angle is which. The smallest angle is always opposite the shortest side. The middle angle is always opposite the middle side. The biggest angle is always opposite the biggest side. Okay, when you think of that, you want to be able to draw an arrow from the angle you're thinking about to the opposite side. So for instance, the smallest angle to the shortest side, look, let me start here at the smallest angle, that's my 30-degree angle, and I could draw an arrow straight to the short side. Okay, just the same if I were starting at the middle angle, that's 60-degree angle. I could draw an arrow straight from that 60-degree angle right through to the other side. And last of all, if I were starting at the hypotenuse, I could start at the 90-degree angle and draw straight across to the hypotenuse. This is really, really important because if I give you a triangle that doesn't look exactly like this, but that has 30, 60, and 90, you should be able to tell me which side is the short side, which side is the middle side, and which side is the hypotenuse. Okay? You want to memorize this triangle. Okay? You want to be able to just draw this triangle without even having to think about it. So go ahead, let's say, take 40 seconds now, okay, and copy down this triangle and this slide into your notes. start to wrap up. Okay, so that's the 30, 60, 90 triangle. Once again, called that because it has a 30-degree angle, 60-degree angle, and a 90-degree angle. You want to memorize that, and you want to be able to draw this model triangle from memory. Okay, let's move on to the 45, 45, 90 right triangle. Okay, you can see right here, again, we call it this, the 45, 45, 90, because of its angles. 45 degrees, 45 degrees, 90 degrees. Okay. In this triangle as well, let's take notice of what the sides we have are. Okay. Let's see. We have two legs that are the same length. If you remember from geometry, sides in a triangle that are opposite angles that have the same measure, those sides have the same length. So you can see right here, this 45-degree angle and this 45-degree angle, this 45-degree angle is opposite a side of length 1, and this 45-degree angle is also opposite a side of length 1. Okay. So they have the same angle. That means they correspond to sides of the same length. The only other side then is the hypotenuse. The hypotenuse corresponds to a side of length root 2 in the model triangle. Okay, so in the model triangle, the legs have length 1, and the hypotenuse has root 2 length. Now, just in case this is a point of confusion, just so you know, root 2 is bigger than 1. Root 2 is bigger than 1. It's about 1.414. So the hypotenuse, as usual, is our longest side here. Now you want to memorize this triangle as well. Okay, you want to be able to draw this model triangle from scratch. So go ahead, take 40 seconds, get this down. All right. Now here's the key idea, and this is why we talked about what similar shapes were before. When we're dealing with these special triangles, these 30, 60, 90 right triangles and 45, 45, 90 right triangles, typically we're going to be dealing with the same triangle just in different sizes. Okay, so you can see right here in the middle, this is the modeled triangle that I just showed you. This is the model triangle I just showed you. Now look, it's got a 30-degree angle, and opposite the 30-degree angle, it's got the short side, which is 1 unit long. It's got the 60-degree angle. Opposite the 60-degree angle, it's got the mid side, which is root 3 units long. And opposite the 90-degree angle, it's got the hypotenuse, which is 2 units long. Okay. So now what I want you to do is I want you to imagine that once again, you take your iPhone, and starting with that regular size triangle, you just actually pinch it down and make it smaller. Okay. It's the same shape, but the sides are shorter now. The sides are shorter now. And that's what we have right here. Okay. We have a 30, 60, 90 right triangle. Opposite the 30-degree angle is the short side again, and that's 1/2. This time, instead of being 1 unit long, it's half as big. It's 1/2. Opposite the 60-degree angle, well, look, we also take that root 3 and we divide it by 2 as well. So now the middle side is root 3 over 2. And the hypotenuse Okay, it used to be 2, but this triangle is half as big. So now the hypotenuse is only 1. You can go the opposite direction too, starting at that model triangle. You can figure out, okay, well, look, instead of starting right there, what if I just make it bigger? If I make it bigger, and take a look right here, that's exactly what we do. We go from a short side of 1 to a short side of 2. Okay, well then, our middle side, since it's twice as big as in the model triangle, our middle side is now 2 root 3, and our hypotenuse is now twice as big as the old hypotenuse, which is 4. This is the same triangle, just in different sizes. Okay, so the question is, suppose I give you one of these other triangles, not the model triangle, but one of the other triangles. Can you figure out how long some of the missing sides are? Let's take a look at a problem that we might see. Okay, a little puzzle. Okay, so suppose I give you this triangle. I want you to find the missing sides. Okay. Let's see, first of all, what information have I given you? I've told you that there's a 90-degree angle and a 30-degree angle. And I've told you that opposite the 30-degree angle, there's a side that's 3 units long. Okay. So the first thing we got to ask ourselves is, well, look, we got to figure out, is this a special triangle? And if it is, which kind? Okay, so let's think. We have a 30-degree angle and a 90-degree angle. We know what the missing angle here is because the 3 angles have to add up to 180 degrees. So this missing angle is 60 degrees. That's 60 degrees. So do we have a special triangle here? No, I actually want you to say out loud whether we have a special triangle here. Yeah, exactly right. Yeah, we have a 30, 60, 90 special triangle. Okay, we have a 30, 60, 90 special triangle. So now we actually need to draw the model triangle and label all of its sides. This is a really important part of the process. Okay, so let's draw that model triangle. Okay, this is our 30-degree angle on top. This is our 60-degree angle. And this is our 90-degree angle. Now, opposite the 30-degree angle, opposite the shortest, the smallest angle is the shortest side. Okay, and that's going to be 1 unit long. Opposite the 60-degree angle, that's going to be the middle side. And that's going to be root 3 units long. And last of all, opposite from the 90-degree angle, that's the longest side, in other words, the hypotenuse. And in the model triangle, that's 2 units long. This right here is the 30, 60, 90 model right triangle. Okay. Now we have to go back to the problem triangle and label the sides here as well. So this 30-degree angle, opposite is a side that's 3 units long. So we know that because it's opposite the smallest angle, this 3 units, this is the shortest side. Okay, now opposite the 60-degree angle is this side. Okay, so this is actually the middle side. Okay, we don't know how long it is yet, so let's call it, I don't know, B. And last, opposite the 90-degree angle is the hypotenuse. I'll draw a dotted line there. Opposite the 90-degree angle is the hypotenuse. Okay. And we can call that, I don't know, let's call it X for now. It doesn't really matter. Okay. Now, after we've drawn our model triangle, the correct model triangle, and labeled the sides and the missing sides in the problem triangle, it's pretty easy. All we do is set up proportions using one side we know and one side we don't know. Using one side we know and one side we don't know. Okay. Now, you could start with any side you want. We're going to start to find the mid side, which we've called B. Okay, so here's the idea, right? We want to find out, in this case, how big the middle side is. Okay. the side that we know is the short side. Okay, so we know the short side. We want to figure out the mid side. That means let's go to our model triangle that we drew, and we'll circle those same sides. Look, our mid side, that's right here. And the short side, look, that's right here. Okay, so now we'll set up a proportion using one of those sides that we do know, that's the short side, and one of the sides that we don't completely know, that's the mid side. So let's see. I'll do it in red here. Let's see. We'll say mid 1 divided by short 1 equals mid 2 divided by short 2. Okay. Now we know the middle side for the model triangle, that's root 3. And let's see, mid 1, short 1 should be in the same triangle. We know the short side in the model triangle, that's 1. Let's see, mid 2, that's in the problem triangle. Looks like we don't know that yet, so we'll just keep calling it B for now. And short 2, looks like that's 3 units long. Okay, so now we can go and solve this proportion for B. Remember, when we're solving proportions, we'll cross multiply. So 3 times root 3, 3 times root 3 will give me 3 root 3. And 1 times B will give me B. Okay. So that means that the middle side here is actually equal to 3 root 3 units. 3 root 3 units. Okay, so take 20 seconds. Make sure you have this down before we move on. We found the mid side. All that's left now is to find the hypotenuse. We don't know the hypotenuse yet, but we'll find that in 1 second. So take 20 seconds. Make sure you're on the same page. Okay. Okay, so in the last step, we found the middle side, 3 root 3, but we still didn't know the hypotenuse. So in this case, we'll do the same thing again. We'll choose one side that we know. In this case, let's use the short side again, and one side that we don't know. In this case, we'll use the hypotenuse, because we don't know the hypotenuse in our problem triangle. So you can see I set up the same proportion here, the same type of proportion. Short 1 divided by hypotenuse 1. Let's go with my model triangle. And that equals short 2 divided by hypotenuse 2. Okay, so that's in the problem triangle. So that's, let's see, short 1 is 1 unit long. That's how I got that. Hypotenuse 1 is 2 units long. That's how I got that. Short 2 is 3 units long. So that's how I got that. And hypotenuse 2, well, I don't know how long that is, so I just put x. Then I cross multiply, and I get 1 times x equals 2 times 3. Okay, well, 1 times x is the same thing as x, and 2 times 3 is 6. Okay, so now we know, look, x, this missing side, the hypotenuse is 6 units long. Okay, so the second step is to just do the same thing you did the first time to solve for the other missing side. Okay, take 30 seconds. Make sure you've got this down. Okay, let's try one again. So let's see. First of all, let's check what we've been given. We want to find the missing sides of this triangle. Okay. Let's see. We know we have three angles given to us, 45, 45, and 90, and we have one side given to us, 31. So let's start by thinking, which kind of special triangle do I have here, if I have one at all? And in fact, we know that it's a 45, 45, 90 right triangle. So let's draw the model triangle. We'll draw the model triangle. Let's see, we have a right angle there, 45 degrees, 45 degrees. Okay. These are the two legs. That's a leg, and that's a leg. And in the model triangle, in the model 45, 45, 90 triangle, okay, each of these legs is 1 unit long. Okay, this side, of course, we call the hypotenuse, and in the model triangle, it's root 2 units long. A really common mistake people make here is that in the 45, 45, 90 right triangle, they accidentally make the hypotenuse 2 units long and not root 2 units long. Really common mistake. It's 2 units long in the model 30, 60, 90 right triangle, but for the 45, 45, 90, it's root 2 units long. Okay. Then let's go back and label right here in the problem triangle. Okay, let's see. Opposite from the 45-degree angle, that's going to be a leg. Okay. Opposite from this 45-degree angle, that'll also be a leg. And let's see, since we know that this leg is 31 units, and the two legs of a 45, 45, 90 have to be the same length, we'll say, all right, well, that's 31 units as well. Okay. Now let's see, opposite the 90-degree angle, that's going to be the hypotenuse, but we don't know how long that is yet. So for now, let's just call it x. Okay, that's going to be what we'll have to figure out. So let's see, let's set up a proportion using one side we know and one side we don't know. Okay, so first we'll work with the legs, because it looks like we know how long the legs are. So that'll be a leg, and that'll be a leg. And then we want to figure out how long the hypotenuse is. Okay, how long the hypotenuse is. So we circle the hypotenuse there, and we'll figure out how long it is compared to the hypotenuse in our model triangle, which we do know. Okay, so that means hypotenuse 1 divided by leg 1 equals hypotenuse 2 divided by leg 2. Now, some of you may be wondering, does it matter which triangle I choose to be leg 1, or excuse me, to be triangle 1, and which triangle should I choose to be triangle 2? Doesn't matter as long as you're consistent. Okay? As long as hypotenuse 1 and leg 1 both come from the same triangle, and hypotenuse 2 and leg 2 both come from the same triangle. Does not matter. Okay, so let's plug in what we know. Hypotenuse 1 right here, okay, we don't know how long that is, so we're going to call it x. So x divided by leg 1, which is 31 units. Okay, that equals hypotenuse 2, which in this case is root 2 units long, and leg 2, which is 1 unit long. Okay, we've got this proportion nicely set up. Let's cross multiply to solve. 1 times x equals 31 times root 2. Okay, well, 1 times x is just x. And 31 times root 2, well, that can't really be simplified at all. So we'll call it 31 root 2. Okay. If you wanted to get an estimate on the calculator of how big that actually is, you could punch it in. 31 root 2. Oops. It's about 43.8 units long. Okay. But I really would like your answer in this form with the square root. rather than going for a decimal approximation. So take 25 seconds, make sure you've got this problem copied down, and you're all ready to go. All right, let's try another. We want to find the missing sides once again. Okay, let's start by figuring out what do we know about this. We know a 60-degree angle and a 90-degree angle. That means we know the other angle that's left over is going to be 30 degrees. Okay, let's see. We know that opposite the 60-degree angle is a 13-unit side, so that's actually going to be the mid side because it's opposite the middle angle. Okay, that means this 30-degree angle, opposite the 30-degree angle, it's going to be the short side, but we don't know how long that is, so for now we'll call it, let's call it A. And last of all, opposite the 90-degree angle is going to be the hypotenuse, but we don't know how long that is, so for now we'll call it C. So our job is going to be to figure out how long exactly A and C are based on how long this middle side that we've been given is. Okay, so we know this is a 30, 60, 90 right triangle. First thing we want to do is on our paper, draw the 30, 60, 90 right triangle. So let's take care of that. 30, 60 degrees, 90 degrees. Opposite the 30 degrees is the short side, which in a 30, 60, 90 is 1 unit long. Opposite the 60-degree angle is the mid side, which is root 3 units long. And opposite the 90-degree angle, is the hypotenuse, which in the model triangle is 2 units long. This right here is the model 30, 60 degree, 90 degrees right triangle. Okay, once we have that, we can start setting up our proportions. So let's start by choosing one side we know. First, we'll do the middle side as the one we know, and the one side we don't know. So how about we solve first for the short side? So let's see. Short 1 divided by mid 1 equals short 2 divided by mid 2. And again, we chose that because short is a side we don't know, mid is a side we do know. Okay, so we want one side we don't know, one side that we do know. Okay, well, let's see. Short 1, that's A, because we don't know it yet. Mid 1, that'll be 13. Short 2, well, let's look in our model triangle. The short side is 1 unit long, and the mid side is root 3 units long. Okay, we'll cross multiply. Let's see, A times root 3 equals 13 times 1. In other words, A times root 3 equals 13. Well, to get this A by itself, we have to do the opposite of multiplying by root 3, which is dividing by root 3. Okay, so on the left-hand side we have A, and on the right-hand side we have 13 divided by root 3. Now here, we got a problem, okay, because this is really impolite to have. It's really bad form to have a square root, an irrational number, in the denominator of a fraction, on the bottom of a fraction. Okay, it's kind of gross, right? It's like walking around with a piece of toilet paper stuck to your shoe, or walking around with a big chunk of spinach stuck in your teeth. Okay, so it's my job as a math teacher to point this out to you. Okay, so be like, hey, this is really awkward. I thought you should know. You have a big piece of spinach in your teeth. You have a big irrational number in your denominator. You got to take care of that. It's kind of gross. Okay, so the way we deal with that is by rationalizing the denominator. And the way we do that is by multiplying this by a creative form of 1. Okay, and that's what root 3 divided by root 3 is. Okay, that's a creative form of 1 because root 3 divided by root 3 is 1. Okay, and this does nice things for us. 13 times root 3, 13 root 3, and root 3 times root 3, well, that's the square root of 9. So that becomes 13 root 3 divided by the square root of 9, which is 3. Now we think, okay, well, is there any number that goes into both 13 and 3 other than 1? And there isn't. So we're actually done right there. We're done simplifying. 13 root 3 over 3, that's how long a is. 13 root 3 divided by 3. Okay, and let's figure out the last bit. Okay, the last missing side that we don't know, that's the hypotenuse. It's the hypotenuse C. So again, we're going to use one side we don't know, one side we do know. So let's say C is the hypotenuse, so we'll say hyp 1 divided by, we'll say mid 1. Okay. And then that equals hyp 2 divided by mid 2. Let's fill it in. Hyp 1, we don't know, that'll be C. Mid 1 is 13. Hyp 2 is going to be 2. And mid 2 will be root 3. Okay. Again, we'll cross multiply. Root 3 times C and 13 times 2. Well, that means C times the square root of 3 equals 26. Okay. Again, we'll divide both sides by the square root of 3. And let me just draw a line here so we have more room. Keep our work nice and organized. So back to this. We divided both sides by the square root of 3. On the left-hand side, we now have C. And on the right-hand side, we have 26 divided by the square root of 3. Again, really impolite. I mean, it's just really gross, okay? So we got to deal with that. And again, we deal with it by multiplying by this creative form of 1. We take whatever's on the bottom. We say, okay, we'll multiply by root 3 divided by root 3. Okay, well, that means 26 root 3 on the top in the numerator and the square root of 9 in the denominator, which means 26 root 3 divided by 3. And now think, well, look, does 26 divide evenly into 3? And the answer is no. So we know that C is 26 root 3 divided by 3. And at this point, we've found all of our missing sides, so we're good to go. Okay, we're going to try one more problem together. Take 25 seconds before we move on to that. Make sure you have this down before we try one last problem. Okay, last problem. Let's do this up real quick. We want to find the missing sides of this right triangle. First of all, let's figure out what we know. We have a 90-degree angle, and we have one 45-degree angle. That tells us that the other missing angle, or the other angle, is actually also 45 degrees. Good, good, good. And we know that opposite this 90-degree angle is a side that's 14 units long. Okay, 14 units long. So, in that case, we know that this 14-unit long side, since it's opposite the 90-degree angle, that's going to be our hypotenuse. Okay, and these two sides, since they're opposite the 45-degree angles, they're going to be our legs. The legs of our 45, 45, 90. But we don't know how long that is. For now, whatever, call them x. And we'll figure out how long that x is. Okay, so we can see right now we have a 45, 45, 90 right triangle. So let's go ahead and draw our model triangle. Let's see, we have 45 degrees, 45 degrees, and 90 degrees. Okay. Opposite the 90-degree angle, that's the hypotenuse. Opposite the 45-degree angle, that's the leg. And of course, we have another leg as well. In our model 45, 45, 90, in our model 45, 45, 90, the legs are 1 unit long, and the hypotenuse is root 2 units long. Okay, so now here's the kind of thing I love about this problem. The thing I love here is we only have to solve for x a single time. And then because we know that 45, 45, 90s have legs that are the same length, we know that the other leg will have the same length as whatever one we find. So let's go ahead and do that. Okay. We want to choose one side we know and one side we don't know. Okay, well, the side we don't know is the leg. And the side we do know is the hypotenuse. Okay. And we'll match those sides from the model triangle as well. The side we didn't know was the leg. So let's see, the leg in the 45, 45, 90 triangle, and the leg and the hypotenuse, excuse me, in the 45, 45, 90 triangle. So let's fill in those sides. Leg 1, that's x. We don't know how long that is. Hypotenuse 1, that was 14. Okay, let's see, leg 2, that's 1 unit long. And hypotenuse 2, that's root 2 units long. Okay, and of course, we got to put our equal sign in the middle. Okay. Let's see. Now we want to cross multiply. So we get x times root 2, and that equals 14 times 1. In other words, that's x times root 2 equals just 14. We got to get our x by itself, which means dividing both sides by the square root of 2. That's to undo the multiplication we have going right now. Okay. So we get x, and that equals 14 divided by root 2. Again, really gross. I mean, just, it's bad form. It's bad manners. So let's deal with that irrational denominator. The way we'll deal with it is by saying, okay, well, look. Okay, let's multiply it by this creative form of 1, root 2 over root 2. Okay, so on the top, we get 14 times root 2. And on the bottom, we get the square root of 4. Okay, now in this case, look. 14 root 2 on the top, but look, the square root of 4 is 2. Now we got to think, are there any numbers that go into both 14 and 2? And the answer is, of course, yes. Okay, 2 goes into both 14 and 2. So this is like saying 2 times 7 root 2 divided by 2 times 1. Okay, well, our 2's are going to cancel out there. And what we're left with is x equals 7 root 2 divided by 1. In other words, x equals 7 root 2. That means the missing side here, x, is 7 root 2 units long. Okay. And the other leg that we didn't know, that's of course also 7 root 2 units long, because the two legs are the same length. Okay. So just to review one more time, all we got to do, we figure out what information we've been given, we figure out what kind of special triangle we're dealing with, 30, 60, 90, or 45, 45, 90, and then we set up proportions using one side we don't know, in this case that was the leg, and one side we do know, in this case that was the hypotenuse. Okay. Now the key to this whole thing, the key step in your figuring out how to nail these problems down is to memorize the two types of special triangles. You got to memorize those two types of special triangles. The first one was 30, 60, 90 right triangles. 30, 60, 90 right triangles. And the second one was 45, 45, 90 right triangles. Hopefully you have these in your notes by now. Okay, so let me put that last slide back up. Okay, take 25 seconds to copy this down. Make sure you've got it. Okay, and before we finish up, boom! Today's shout-outs go to Christian and Mimi. Keep up the good work. Keep doing what you're doing. Keep hustling hard. All right, y'all, this is Mr. Paul signing out. I'll see you in just a few seconds because you're in class right now. Later.